All right, welcome back everybody. We were in Fort Lauderdale for that last segment, and we're in Stuart, Florida at Murray Ventilation Products for this segment. We're here with Mike Murray at Murray Ventilation. How you doing, Mike?
I'm good. How are you today?
Really well, thanks. And
good.
Thanks for having us here.
It's a pleasure to have you.
Our conversation today is about air inlet filtration and air circulation, primarily through engine spaces. So it's kind of one of those things, Mike, that people take for granted. It's I guess a design element that the naval architect inputs into the design of the boat, and the brokerage community, the sales community, even the repair and refit community doesn't really think twice about it.
No. And in the truth be told, it doesn't really affect the mission of the boat, whether it be a fishing boat or a pleasure yacht or a commercial vessel or anything, unless it results in the breakdown of machinery.
Well, and that's the key here is the machinery is not going to operate properly unless we have a balanced airflow. The key to that is having clean air, and one of the things that we've learned in the last several years is the ability to remove the moisture from that air as it comes into the engine room. So there are two components that we're going to talk about here in this segment. One is the filtering the air when we bring it in, and one is the circulating of air and what the purposes of those two systems are. Let's take a look over here. We got a couple of exhaust fans, or are they inlet fans?
Well, there's one of each actually. This is
okay.
To what you were just speaking about.
The air comes in, the air goes out.
These are a set of fans that are going in a yacht.
Okay.
That gets its engine combustion air naturally. So in other words, open louver vent. The air for the engine is provided naturally to the turbos without any aid of fans.
So it's just ambient, it's not pressurized.
Correct.
Okay.
So it'll actually make a slight negative pressure.
Okay.
But again, we size the openings to make sure that we don't have undue pressure losses so the engines aren't starving. So these fans are going to provide an air current in and out to maintain a certain temperature in the engine room so that the engines don't derate, so your electronic equipment doesn't derate, and you don't have big failures.
So there are a couple of principles that I think I'd like to speak about with regard to all this. Number one, any of us that have been around the industry for a while, we've walked on board a boat and gone down in the companionway, and we've seen black soot around the carpet at the engine, at the bilge hatches.
Yep.
Why is that? How does that happen? What's
well,
that about?
It turns out Berber makes a great filter.
Great.
So what's happening there?
I don't think that was the idea.
No, not the intention. So what's happening there is there's insufficient air openings for the engines to pull air from the exterior. And what happens then is you wind up pulling through a salon door or through a hatch or through some other spot, and then you couple that with a little station wagon effect with a little bit of exhaust behind the boat, and the engines, which by the way, they will get their air. They can pull a lot of vacuum. They pull through the salon door, they pull through hatches, and it winds its way through the living spaces down in, and then the soot gets caught in the carpet, and you wind up with a perfect outline of the soft patch or the hatch underneath the carpet.
Okay, so the first thing that we got to consider is we've got to have the proper amount of air, because an engine is basically an air pump. Air in, air out, combustion creating that movement. So was there a rule of thumb? Was there any, how did they figure this out in years past when they first started doing?
Rule of thumb is exactly what pretty much all the engine manufacturers back in the day, and unfortunately still to this day would say so many square inches per horsepower, but it really doesn't take into consideration different displacement engines and so forth. However, engine manufacturers also provide empirical data saying this engine at this horsepower at 100% load consumes this many cubic meters per hour or cubic feet per minute, and that gives us the exact point at 100% load what that engine requires.
Okay.
So hopefully people aren't going to operate like that too often unless you have an emergency and you have to get home.
Right.
So we try to design for that scenario from a new build standpoint. Unfortunately, with refits, we can't often get to that. So
well, refit brings in a completely different element, because what we also find in today's marketplace is that there's different horsepower available in smaller footprints and in lighter components. So people are, let's say we take a pair of 1271s out, well, we'll replace those with an inline 6-cylinder Caterpillar, as an example, and you've got a much smaller engine that's lighter, but developing the same amount of horsepower. is it requiring more air? Is it requiring different flows?
Sometimes yes, sometimes no.
Okay.
And then again, depending on which manufacturer you use, some engines are a little bit hotter running than others.
Okay.
Some engines have more jacket water cooling, so they're a little bit cooler.
Okay.
But we have to look at each one on a case by case. And then what we do here is we do an analysis based on the specific boat that we're working on.
Okay.
How much air do we require for combustion? How much cooling air should we have through the space to go back out? And then try to balance that.
Let's talk for a quick second about the cooling air component of it. What we've been talking about to this point has been combustion air, needing to have a certain amount of air, unrestricted flow, properly filtered into the engine compartment in order to have the engine run efficiently and combust properly. What other components and considerations do we have in the engine room that we have to think about with ventilation air?
Sure. So in addition to consuming air, which varies with RPM, the engine will get to temperature, your engines will get to temperature, your generator will get to temperature, and then also there's other equipment if you have
exhaust manifold gets to a high temperature.
You could have compressors in there that generate heat. You can have a power transformer, which admittedly won't be running while you're running, but that'll generate heat. So all these things need to be taken into consideration as heat sources.
Right.
And again, data is available for radiated heat, whether it be in kilowatts or BTUs per minute. And then what we do here is we do a thermodynamic analysis on that.
Okay.
Assume, unless we're in the Middle East, 95 degrees or 35 C ambient. And then the engine manufacturer's machinery specification will call out what their ceiling is, whether it's 50 C or 122 degrees or somewhere in there in that range. So we try to maintain that differential between that differential so that everything in the engine room is happy. So we do that by you do a thermodynamic analysis. It comes up with a volume of air we need.
Okay.
So we have a volume of air that needs to be passed through there and removed, not just circulated.
Right.
It's the old pot of boiling water thing. You can stir it up; it'll just all be hot. So air has to be introduced and removed for cooling in order for it to be efficient.
Well, and that's you mentioned the pot of boiling water, and that's very interesting because most people don't think about the fact that air is fluid. Air is a fluid. It has a flow, a current, disruptions.
Absolutely.
There's turbulent, there's laminar flow. There are a lot of different ways that we can move air around. And what we want to do is we want to make it efficient. We want to introduce the proper amount that we need, but not too much.
Right.
Because if we introduce too much, then that creates other problems on the other end of the spectrum,
Absolutely.
right?
Absolutely.
Okay.
Absolutely.
Plus having to have much bigger holes than we need in order to allow that
Oh,
air
absolutely.
in.
I mean, there's a number of things. So you've got expense, bigger equipment. You've got power consumption.
Okay.
And you've got
Structural
real estate. You've got
considerations.
physical, weight constraints and actual size of equipment. So
Right.
It's very important to size things as best as possible.
So the first thing that we looked at, just coincidentally, was inlet and exhaust fan housings that will enhance circulation of the air.
Correct.
So let's take a look at a louver that gives you the ability to shut off the airflow or open the airflow, and then we can take a look at the science behind how we remove the moisture from the air, because that's the secret sauce
Oh,
that
absolutely.
didn't exist in years past.
Yep. So these products that we have here, this is what we call it is a fire damper. Now this is an aluminum fire damper that's been powder coated. You can see a frame here we're in the middle of construction, so we prep this to get powder coated and then send it out. We do that solely for the purpose of the fact that we are a marine manufacturer and raw materials aren't going to last as good. This is a better product for us, for our clients.
So fire damper, is that a requirement under
It
code?
is depending on the classification of the boat.
Okay.
So the most stringent would be an A60 requirement, which this damper does not meet. We do sell A60 dampers. They're stainless steel.
Okay.
And what A60 means is it's a fire test where they burn a furnace at, I believe it's 1760 F for an hour.
Okay.
And the damper has to maintain a temperature differential as well as integrity without failing.
So in the event that you have a fire,
that'll close. Yep. Now this will close with this actuator. So what this is an electric actuator. This one happens to be 24 volts.
Okay.
So the way this becomes fail-safe, and this ties in with the fire system on the boat, is that this damper is held open with power.
Okay.
And it's a fraction of an amp to hold it open.
Okay.
So this actuator is tied in with the fire system.
Okay.
So when the fire system discharges, it opens the circuit, cuts the power, and this damper will spring closed.
Slaps
and
closed.
stay closed.
Okay.
Yeah.
All right. Thereby preventing the fire from getting through.
Correct.
Okay.
Correct. So that this is something. I have also seen situations where we had a boat, which we always talk about heat. We had a boat in the Arctic that wanted to keep the heat in the engine room.
Capture the heat.
So
Sure.
we were able to put make a custom control where they could close the dampers and keep them closed to try to maintain a little bit of heat.
So it's thermostatically
Well, what we
controlled.
did there also is we also had a safety there where they couldn't start the engines with the dampers shut.
Okay.
Because that would be a really bad thing.
Yeah, you kind of want that air.
Absolutely. So,
Yeah.
so anyhow, so these are fire dampers. That's really their only purpose.
Okay.
We see almost all the bigger yachts and even some production boats are putting them on. It's good. It's good practice.
Okay.
Certain classifications will allow them not to have them, but then the fire bottle, the fire system has to be oversized to allow for leakage.
Okay.
So that's the skinny on that.
So that's the damper itself.
Yep, that's a fire damper.
So let's
So
go.
but the first line of defense
Right.
is the moist air being drawn in.
Okay.
So we want to stop the moisture. We want to stop the salt droplets from getting through there and making their way to a turbo intake, so that your air sep filter is just for dust and not trying to stop water, because at that point, very often it's too late. You've been in a business forever, and we've seen some pretty catastrophic failures as a result of that.
I've seen a few messes,
Yeah,
absolutely.
yeah.
And it's interesting that you mentioned that, because air sep is the piece that is probably the most famous around the industry as the newer technology, even though it's been probably, 40 years now, that filters the air going into the engine.
Right.
But what we want to do is we want to filter the air before it ever enters the engine room.
Correct.
Because of all the other components that are in there, not to mention just the engine.
A catastrophic failure in your main engine is awful. However, more and more now we have so much ancillary equipment in the engine room, electronic equipment, and having moist salt air in there is just awful.
It's a bad thing.
Awful, yeah.
So let's take a look at what we would call our air inlet filter system. And these are hull side vents, if I'm not mistaken.
These are, yeah. These are actually, what this is pretty interesting project. This is a 1986 54 Bertram.
Okay, so talk about refits.
Sure. So Bertram used to have what, you've been on Bertrams with 54s. We've
I was
all
on
been
86 54s when they were new.
Caught my first Blue Marlin on one of those, as many people
go.
did. So they had hull topside cowlings
Scoops.
that used to take your toenails off when you walked up the gunnels,
Got
and
the scars
a
to prove
small rectangular opening for combustion air.
Okay.
So this is a customer that wanted to modernize this boat, because now we do supply Bertram presently with their ventilation. So Bertram got him in touch with me, and I went out to the boat, and he wanted to modernize the boat and make it look a little better. So what this is actually, it's two things here. We have a grill, and this is really just for aesthetics.
Okay.
So this grill, this horizontal grill you see, is going to be seen on the side of the hull.
So to know in the side of a 54 Bertram has the step. This is the port side of the boat.
This will be port
there's
side,
your
yep.
gunnel. There's where it steps down, and then there's your cockpit gunnel
Yeah,
going
that's correct.
aft.
So
Okay,
this
is
angle,
the
forward to aft, this angle matches the rub rail.
Okay.
And then this angle matches the broken shear on the old 54 Bertram. So this, rather than a rectangular opening, this is a much more aesthetically pleasing.
It looks like it belongs.
Yeah. However, keeping in mind function. So we have enough open area here to feed the engines in this boat.
Okay.
Okay. But behind it, and it's hidden, is this back louver, which is a mist eliminator. So this is a series of louvers that forces the air to turn hard, first forward and then aft, with hooks in. And I'll show you a sample of what that is in a second.
Okay.
To stop the water. So this is actually the bottom. So this would be sitting in the hull like this.
Right.
And if you put this upright, you'll see that the bottom of this box is angled. And the reason for that is once it catches the water, it slides the water forward. There's a space here where that's open, and the water ejects right back out the
the
whole
water
side.
to drop right out.
Correct.
Okay.
Correct. So there's no plumbing, no filters, no maintenance. This gets installed. This will be painted. This is PVC board, which holds paint very, very well.
Okay.
It'll look fantastic, like it was built on the boat. And happy days, they go on, and they have a louver that's sized correctly.
It's a maintenance-free item.
Maintenance-free.
Okay. So you install it, you paint it, you
Paint
install it, and it
That's-
does its job.
And that's the end of it.
Okay, no
Correct.
moving parts,
Correct.
nothing to deal with
Correct.
after the fact. We've got a better view of, you were talking about the veins in there.
Correct.
And you said that the water, the air with the water in it will hit the filter, and then it eliminates the moisture.
That's right.
Explain to me a little bit about how that works,
Okay.
because it's not intuitive.
So that product we just looked at is mounted on the exterior of the hull.
Okay.
This one would be mounted in the engine room from inside the engine room. So the builder, so you'll have a hull vent which they provide,
Right.
and hopefully we get involved with that, with the engineers to make sure that the opening is commensurate with the engine package they have.
Okay.
So the air comes in with the water,
Right.
drops down through the salon sole into the engine room, and then the builder builds a plenum box up against the hull, and this will mount in the plenum box from the inside of the engine room.
So in the engine room, that's what you would see.
So you will see this in the engine room, and oftentimes there'll be a damper on the front of it to close it off. But this product right here, like we're looking at right here, you see the louvers are like this, and the hooks on the front.
That's what I wanted to understand.
Right, so this is a port side, like so. So what you see here is the air is going to be coming from this side.
Okay.
And then as the air is forced to turn, there's a hook
in here,
which catches the water.
Okay.
So centrifugal force forces the water, which is heavier, up against the face of this louver.
Okay.
And it slides into this hook and then drops down. And then we have these big drain slots at the bottom to drain the water out of it. And then when it turns the other way, on the back side, it's harder to see, but there's a smaller one here, just in case you have an extremely heavy load of water. Yeah.
Okay.
Yeah. But here, let me grab a louver.
Okay.
Brandon, what did you do with that louver I set over here? I know, where did it go?
Okay.
Okay. So this is the louver this one is a 3-inch. This one is a 4-inch. We also have a 7-inch louver. So
interestingly, if you set this one by this one here, the angle is very different when you get into the smaller one.
Correct. We just developed this smaller louver at the request of some customers that were building some boats that had really, really tight spots, and they still wanted to use these products. Okay. So there's always a trade-off. So we have shallower box.
Right, the box is.
However, because of the angular construction and the harder turns, you'll get a little bit higher pressure drop.
Okay.
So there'll be a little bit of loss through it in terms of pressure drop. The 4-inch one has a little less pressure drop because it's a little bit smoother curve, and then there's a 7-inch one which is even smoother.
Okay.
So that has the least pressure drop. However, it occupies more physical space, you know.
But going back to the original comment that we made about the fact that air is a fluid.
Oh, correct.
So if we make the bend less of a bend,
right,
then it's going to flow more easily.
It's more laminar when it comes out the other end, and it flows easier. So
and thereby creating less pressure drop from the outside to the inside, which means theoretically, if it's thicker, we could make it a little bit smaller because we still are able to provide the same volume of air inside.
That's correct.
If we're going to have a thin product like this, we theoretically may have to have a little bigger opening.
Right, that's correct.
In order to be able to capture enough air.
So in order for these products to work correctly, there is a range of velocity where they work very, very well.
Okay.
And I mean 99% efficient for droplets to 10 microns.
Wow, okay.
So we want to size, for instance, for this size mist eliminator, somewhere between 650 feet per minute up to about 800 feet per minute if it's natural draft, meaning no fans. So if there's just the engines pulling through, which on a production boat is most often the case. Okay. So we try to size this at that size. So at that size, you're looking at a 0.2 inches of water pressure drop, which is imperceptible. You know, for instance, if you're running and you try to open the hatch, you know, you'll feel air when you lift the hatch, but you won't be able, you won't have to fight the hatch to get in there. Yeah. In fact, that's a pretty good indication that you're undersized. If you try to open your engine room hatch and it fights you pretty good, I mean, that's a good layman's way to say, hey, maybe I got to take a look at that.
Or if you go to open the salon door and you can't get it open, you
correct.
got other issues to look for.
But again, to look at this, you'll see. So the moist air, this will be positioned like this.
Right.
So the moist air comes this way. This would be forward. We try to put the hook forward. The moist air comes in. The air has to turn. The moisture gets slapped against this face between the next louver, which is tied into this, catches the water, it drains out the bottom, and then it either goes
through this open space here.
Correct. And then there's an open space here that goes the other way, and then on the back side of the next louver is a smaller hook, which catches anything that might be left over. Okay. And honestly, almost all of it gets caught with this first big hook.
Okay.
And then through the other side is drier air that gets distributed in your engine room and doesn't damage the rest of your equipment. So
right, because your air conditioners, generators, electronic components, battery chargers,
unbelievable amount
all
of
sorts of electrical equipment.
The other thing on a production boat especially is that alley outboard of the engine is most often where you see your ice maker, your AC compressors, all kinds of battery box, all kinds of
directly
equipment
underneath.
Correct.
The air inlet filtration system,
correct,
or whatever inlet filtration system exists in that particular boat.
So now, when we have these products in conjunction with large axial fans, we can up that velocity up to about 1,300 feet per minute.
Okay.
So we get a smaller, smaller area because we're able to pull, because those large fans can withstand a pretty high static loss. So at that velocity, you're looking at about a ½ inch of static there.
Okay.
So which isn't terrible. So the other thing to consider is there's other things that are creating pressure loss in the system. If you have a lot of ducting, there's losses associated with that from friction. Again, there's fluid flow from friction going down that pipe.
Okay.
What kind of duct is it? Is it a flex duct, which is very, very rough?
Or is it smooth?
Or is it smooth? Things like that. So these are the things that we design in, we look at prior to saying, okay, you need this. So we engineer it so that we make sure that we're, to the best of our ability, we're able to provide the air coming out in the space is the air that we want. So we can vary fan diameter size, blade pitch, horsepower to make sure that we balance that and overcome that.
So with regard to mist eliminating filters, what we've seen are hull side vents, cabin side vents.
Yep.
Inside of the plenum, we would have a vent. Over the years, I've been on boats that actually drew air in through the cockpit combings.
Yes.
Up underneath from the back there. Now, obviously, that's not the preferred way because we've got salt, we've got soot,
Right.
it's not the cleanest airflow back there. But
Right.
what do we do in the event that we have a boat that we retrofit that has that sort of a system?
The issue there is, again, finding enough real estate, finding enough cross-sectional area to be able to fit this in. Today, a lot of boats with cockpits have mezzanines, and you can actually use a toe kick and have that void in behind and then mount something like this. There are times when you have to say, this is not attainable, this product won't work. Now, the good thing about in a cockpit, there's not as much salt, but there is a lot of soot. There certainly is a lot, especially a big voluminous boat is going to have a lot of station wagon effect.
Sure.
So it's something to consider. The worst thing you could do is just fill a hole with a product that's not sized correctly, because eventually you get a velocity so high the water will pass straight through this. Then all you're doing is creating a huge restriction, and you're not doing the job you want to do. So that's the issue there. The other issue is if you have ventilation in your cockpit where you're entertaining, or you're fishing, or whatever you're doing, you introduce noise and heat. So if you're expelling air into the cockpit, you introduce heat and noise right there where you might be, which might not be a big deal when you're running, but when you get dockside and you have to cool the engine space down, now all of a sudden everybody's feet are sweating and you can't hear each other talk because you've got a fan roaring. So.
Well, that's an interesting point that you bring up as well, because when we're talking about the end of the day, let's say we've got a motor yacht consideration and we've got exhaust fans. When you shut those motors down, things get pretty hot in the engine room because you don't have the airflow from the boat moving forward. So what solutions are there for that?
Sure, so what we do there is we have a control system which we can fully automate the engine room ventilation system by a number of ways.
We've got a setup over here.
There's actually a control system that goes with those fans. That this particular one is temperature based only. So what this will do is each fan is wired to a variable frequency drive. And then there's a temperature sensor which will be mounted in the overhead of the space. And then through a PLC, we control the speed of the fans based on the temperature of the engine room, and we can set that. So we have a touch screen. So right now it's on manual, but then we can go to an automatic function, and it says stop. Stop means the engine is stopped. So this is set up so that when the engine is stopped, it won't be an auto, but it has what we call a dock run mode. So the dock run mode will limit the percentage that the fans will run, so that in the event that you do get dockside and then you have to serve cocktails or you're just hanging out in the boat, you don't have this. All of a sudden, the only machinery noise are those fans. You don't have engine noise. They can be loud. They can be very loud, absolutely. Especially a high RPM fan can be approaching 100 decibels.
That's loud.
It is. So anyhow, we can automate this to the point that you don't have to touch it. This senses when there is a ignition, and then when the ignition comes on, the fans go on full automatic and they'll operate to full function. When the boat gets back dockside, it goes to dock mode and it limits it. But what that is a compromise. So rather than shutting down and now you have your machinery space getting super hot, again, electronic equipment is only rated for 40 or 50 C, so you don't want it to get hotter than that because you'll damage electronic equipment, which could get extremely costly. So you're still keeping an airflow through there, again, keeping air coming in, air going out, and eventually when the temperature is reached back to the set point, it shuts down. So what this also does is it ties in with that fire system and the fire dampers. So if there is a fire system discharge these fans are disabled.
Okay.
So what that does is your fire retardant gets distributed in the engine room. If there's a fire, these fans shut down, the dampers shut, and then that fire is put out. And then only by pushing a bypass mode can you operate again. So it gives you limited access so that you can get home.
Okay.
So there's a safety built into that.
The last thing you'd want to do is to discharge the fire repellent or fire retardant,
absolutely.
and then
Absolutely.
have it blow right out of there
Correct.
before it gets to do
well,
its job.
if at that point, if you've discharged your fire retardant, if it blows up again, you're going to have to abandon ship because you got a fire you can't stop.
We've had we have a great segment in this week's Yacht Engineering Week about fire retardant with Fire Ranger, and another thing that we talk about this week is exhaust systems.
Sure.
So where it all begins is bringing the air in, and I think we've got a much better understanding of how we bring it in, the importance of having it be dry and clean as it comes in, because it's not just the engines that are using them, but there's so many other things in the engine compartment.
Absolutely.
And then we also have air that leaves the engine room that's not going out through the exhaust pipes that came through the engine, but has to go out because it's evacuating ambient air that's reducing temperature.
Correct.
Okay.
Correct.
So for temperature control. I think we got a pretty good sense of it, Mike. I really appreciate that. You guys, you've been at this a really long time.
Yep.
If I'm not mistaken, you've been dealing with air inlet filtration for probably, 30 years now?
20 years.
20
After
years?
I retired from being a boat captain. Decided to grow up and use my engineering degree.
Many of us have made that decision, fortunately.
Yeah.
But it's interesting to see the progress that's been made, the developments have been made.
Sure.
I'm sure there's new stuff on the horizon, but this really does make a big difference.
Yeah, we're constantly developing new stuff. Like, again, we're talking today about big yachts and things like that, but we also develop some products for even center console outboards.
Right.
Everybody's got flat screens now. Everybody's got big booming stereo systems. Very often, all that's housed in a small console. So we have a very simplified DC system that does similar to this with very small fans. So that's coming to the market next for us. But we're always, like I said, we're always looking for a new product. How do we improve what's going on? That product, by the way, can also lend itself to Lazarete Ventilation.
Okay.
A lot of people are using gyros now,
right?
And if they get put in a Lazarete, it's a really bad environment for them because of the moisture. Okay. So what we do there is not only do we deal with temperature, but we add another sensor for humidity. Okay. So the fans come on at very low speed, and they just keep air passing through there. For instance, in our area here, the average springtime humidity in the morning is 83%.
Right.
If you're over 70%, you're going to be developing black mold.
Right.
So that's very difficult. And in the afternoon, it's 60% because the sun burns it off. But in an enclosed space, that moisture stays all day, and it just, I have to tell you, we've all pushed a chamois around and a rag and some spray nine. So
right.
If we can stop that and help the equipment in those areas out, all the better.
There are maintenance issues, and in fact, there are health issues to be considered as
absolutely,
well.
Absolutely.
The one thing that I want to wrap up with is in the yachting sector, in the boating sector, we've got a fairly small industry to lean upon for research and development. Are there other areas where you guys cater to provide solutions?
Yes, we
do. You do military? Do you do commercial?
We do, certainly.
Is that an area that provides us a lot of ability to learn?
And to what you're saying, the commercial and military sectors often drive what the pleasure boat market does. I was talking to one of the engine manufacturer's sales reps one day and was asking, well, why don't we get a new model with a higher horsepower rating? And he said, if we don't have an industrial use for that, you will not see it in the marine market, because, and I couldn't believe this, the marine market represents single-digit percentages of engine sales.
Low single digits.
Very low.
1.5 to 3%.
Absolutely, absolutely. So we're beholden to that, to the industrial market, to that.
Right.
And we do anything with a diesel engine or anything where we have some heat transfer. We're glad to service that, but we obviously focus on the marine industry. But there are some industrial aspects, like for instance, containerized generators,
right,
which you might see in an oil field, you might see in an oil rig, you could see
sure,
any. So that's another thing. It's nothing more than it's basically a mobile engine room.
Right.
It's a diesel engine sitting in a container.
It's
got to have air coming in for combustion. It's got to have cooling air in, cooling air out. And depending on where it's located, if it's offshore, if it's on a rig, or if it's on deck, then it needs to be conditioned before it gets in. It needs to have that water stop so that the machinery can run.
Excellent. I think that's going to about wrap it up. That's an interesting segment. We're going to break for a commercial, and we'll be back.
Yacht Engineering Week 2021 has been made possible by Pantropic Power, the only authorized Caterpillar Power Systems dealer in South Florida. Florida Nautical Surveyors, your complete solution to all of your vessel surveying needs. And Robert Allen Law, exclusively dealing with the business of yachting. We would also like to thank Quantum Stabilizers, AME Solutions, DeAngelo Exhaust, MPI Marine Professionals Incorporated, Concord Marine Electronics, Lauderdale Marine Center, Marine Data, Isotropic, Dockmate, and Murray Ventilation Products. Thank you for joining us this year. We'll see you in 2022.